Okay, so now we're still in the cubic family and we are looking at the combinations of it. And so when I look at f of x here, I'm going to go straight to my transformations. And I know that this 1 here means I've gone down, or it's plus 1, so I've gone up 1 unit. There is no shift left or right. And then the 1/2 is inside the function. So that means there is a horizontal stretch by a factor of 2. Not 1/2, but 2, the reciprocal of it. There's none of this. These ones are non-existent. So there's 2 transformations. So now when I'm going to sketch this, I know that my base function was here. My base function was this x cubed graph. That's just plain old x cubed. Well, when I move, I'm going to do this transformation. One, I'm going to stretch each of these x values by a factor of 2. So that means it's going to go out here. So this 1, 1 moves out. And so I can also start to make my graph, my table here. I know this is going to go out to 2. This one's going to go out 2. So it's going to actually be more stretched out this way. And then moved up, it goes up 1. And so my graph is going to be, here more so. Something like that. Or this is 0, 1. My pivot point is 0, 1. I know I go 0 and 1. Let's do my -1 and -2. And 1 and 2. If I take my if I put my 1 in there, I'm going to get 1/2 to the power of 3. That's not a very nice number to do. Let's pick a number that's going to work out nicely. I'm going to use 2. If I plug 2 in there, 2 times 1/2 is 1 to the power of 3 is 1. Plus 1 is 2. If I try -2, then I get a -1 to the power of 3, and that gives me a 0. Oh, that's nice. So this value here is -2, 0. I have my y-intercept and my x-intercept. So I know my x-intercept is -2, 0. My y-intercept is 0, 1. And so it needs one more point to label, so I'm going to label this point here, which is 2, 2. Domain is real numbers. The range is also y is a real number. To find the inverse, I switch my x and y values. So it's x is equal to 1/2 y cubed plus 1. Subtract the 1. Take the cube root of x minus 1 both sides. And then multiply by 2. So 2 cubed root of x minus 1 is equal to y. And this is indeed a function here. So continuing through here, let's see what else we have. I know f at 0, read my table, is 1. F at -2, the y value is -2. Well, I don't have, looking at my table here, I know it's going to be somewhere down here. So I'm going to actually have to calculate this one here. So if I'm going to calculate that, here's my function. Let me steal some space here. So I'm going to go 1/2 x cubed plus 1 is equal to -2. Subtract the 1, equal to -3. And then I'm going to do 1/2 x is equal to the cubed root of -3. And then I multiply by 2, x is equal to 2 cubed root of -3. So if I want to do the cubed root of -3, I go to my math menu and I can do the 3. Or I could also do the x if I wanted to, but I'm going to do number 4. And I'm going to do -3, and I get that value. If I wanted to use that other version, if I put 2 I'm going to put the 3 in first, and then if I go to math and now number 5, that 3 I just will put, it'll magically put it into there. And I could also do -3 this way. Oh. And this will give me the same value. So this, you can see, is x equals -2 point, what was it? 2.88 to 3 significant figures. All right, so that's how we can figure that one out. Now, I'm going to erase this. Problem solving, algebraic fluency. We're given this, we want to sketch g of x. Well, I need to take this then and plug it into my function. So I get 1/2. This is my x value, so that goes in for 2 cubed root of, not 3, but x to the power of 3 plus 1. If I simplify that, well, those 2's cancel. The cube root and the 3 also cancel, so I get x plus 1. Well, this is actually quite straightforward. It's a straight line. Y-intercept is 1, slope is 1, and there is my graph. All right. There's no real, if it's asked to sketch, there's no real algebra to be done. All right, continuing on, we want to find the transformation notation of this. Well, inside the function is 1/2. Is 1/2 x. Outside is plus 1. Checking on Desmos. I know this is 0.5 plus 1. There's my function, and I can see that it's the same as what I graphed up here, so that's good. And if I put 0.5 plus 1, I can see that it is indeed the same function there as well. And finally, this last one, given this, evaluate this scenario here. Well, that means r of f of x. That means f goes into r. Well, that means 16. This function goes into it for the x value. So it's 1x cubed plus 1 plus 4. So all of this is the x value. It goes in for x. And now it's a matter of simplifying this. So now I get 16. When I do this, I get 1/8. 2 times 2 times 2 is 8. X cubed plus 1 plus 4. I have to distribute the 16. It's a little bit tricky. It gives me 2x cubed plus 16 plus 4, which is 2x cubed plus 20 is r of f of x, is this particular function here.